is. Um, and you'll get a little notification saying, hey, this is recording. My focus this semester is not going to be on recording faces, but just on the actual content. So it's going to be recording my screen share. It's just going to give you a notice of that. The key to actually being successful in the CSWA is lots and lots and lots of repetition of this. The more of these exercises and things that you guys are willing to do, the much, much better you're going to be come the time you actually have to run the exam. So we're going to do a test at the midpoint of the semester. There's going to be a lot of assignments where some of the tutorials are going to show you some fundamentals, but we're going to start with a lot more of the 2D features and sketches today and see if we have enough time to get into the beginnings of the 2D to 3D transformations. So any questions before we get too far into it? Yeah, I know you guys are going to get probably just about seasick with all of the stuff that I'm doing. So this is part of the reason why I'm going to do recordings, because I expect that you guys are going to be able to go back and watch and rewatch and all of those things, because there's a lot that's going to go into each of these things. Okay, so a couple key fundamentals. For this is right when you finally have it installed. If you haven't gotten it installed, since we've got a few more people in now, if you haven't gotten them all installed, you want to make sure that you get SolidWorks installed. You can get help from some of the other instructors that are teaching this. So most of the mechanical engineering instructors are capable. Some may be more grumpy than others, but that's all right. They'll get over it. Usually, if you ask for help, they'll be kind enough to help out. If not, tell them I threatened to DDoS them or dox them if they don't help you. So um, most of them will be pretty willing. Some of them may have limited time availability, but a lot of them have taught this and are familiar with the install process. So make sure that you are seeking out help, because you guys are going to have to really hit the ground running with the assignments. Okay. So a couple quick things. As you get logged in, you'll start seeing kind of some, once you go to the home, you'll see some options, a screen like this. They used to do a couple other settings in terms of the default for dimensions. Looks like in this specific version that has changed a little bit, which might actually be for the better. So we really want to pay attention to a few key things. So most of the time, what we're going to start with is a new part. So if you guys are at this screen and you're not sure what to do and there's no tools and things, this is new software you've never seen before. You start by going to home, or you can start by going to new. So there are a couple things that that it will want to specify what you're looking for. So usually this is the exact screen that'll pop up as you go to develop a new something, right? So the tutorials that you guys have that are some of the early assignments, these, you click that tutorials button, and what you're going to find is there's a resources tab over here. There's a bunch of different things up here to pay attention to, but the SolidWorks help is one of the more useful ones. So the under let's see where they have it now. This should bring up the actual tutorials, but if it doesn't, just come back to this home button. So it's supposed to pop out on the right side, but it looks like it's not there today. You can go to the home screen and then this Learn tab, and then you're going to look at the step-by-step tutorials. So this is that Introduction to SolidWorks one. So this is one of the first ones that's due. What it'll do is it'll walk you through as you get into some things. It'll allow you some of these orange highlighted circles. It'll highlight for you, hey, this is what's going on. This is what's happening. So some really useful features there, but it'll walk you through. You can go forward and backward. Pretty self-explanatory on the tutorials. And if you go back far enough, you'll see other ones. So we're also later in the semester going to be doing parts and assemblies and some of the other ones. Most all of them that you're going to need are going to be here under basic techniques, pattern features, revolves and sweeps, lofts, the knob, fillets, all of those design tables, all of that stuff is going to be here. And this is where you're going to find it. So there'll also be, I can't remember if we've taken out the photo view or not. But these are things that you'll be using this semester. So that's a little bit about the layout. Settings, there really aren't a ton of things that you need to pay attention to in here at the moment, but what we'll do is we will show how to make a screen that's like 3 screens wide. That's ridiculous. There are a couple things in terms of the actual zoom, and you can search for this y-axis. If you guys don't have a axis for, might be under their display. There's a setting in here that will allow you as you're zooming in and out, it'll allow you to invert the axes so that the zoom actually makes sense. One of the other things you guys are going to want to make sure you get is an actual mouse. If you're trying to do this on a trackpad, you're literally going to lose all of your hair probably by about week 3. So make sure you've got a mouse to be able to do this with. Otherwise, you're really going to be hurting if you don't. So I'm going to research for invert. Maybe they took that feature out, and maybe in this version they finally fixed it. We'll see. We'll see. Because it used to be at one point, I think it was under display. At another point, it was under sketch, and it used to be called invert y-axis. Reverse mouse wheel zoom direction. That's what it is now. So under view, I tend to not like the reversed mouse direction. So that means you have to pull back toward you to zoom in. You have to push forward to zoom out, which makes no sense to me. Maybe if you're left-handed, that's cool. I don't know. But that drives me absolutely bat guano crazy. So that's one of the first things I change when I get into something. So then we go back to our home screen and we can start by creating a new part. So you guys will want to open up a new part file, and this is going to be your new best friend. There's all kinds of things that you can learn from here, but we've got to get into some of the mechanics of using it rather than spending tons more time on this process. So in terms of actually using the interface, learning how to break it, learning what happens. Some of the time you'll have something like this happen where stuff goes away. You can repin stuff using the pin. I always pin the file system because when that goes away, I guess maybe if you're running on a small screen like a Surface or something, that's not going to work. Did anybody in here, is anybody running on a Chromebook and somebody told you that would be fine for engineering? I'm hoping not. If you are, let me know in the chat because you'll need to actually get a laptop or, you know, club your gamer friend over the head and borrow their laptop during class or something. We've had a lot of issues recently with people on Chromebooks, so hopefully nobody's on one trying to do this. If you are, you'll want to make some changes. There's a couple other things where sometimes the command manager, which is what this is, there's a couple different key things under view. So in the workspace and specifically in the toolbar, you can sometimes hit a hotkey and then the command manager goes away and then all of your tools are gone. Students freak out and there's sleep lost over this. You go back to view, you go back to toolbars and enable the command manager. All of the tools are still here, buried under things, sketch tools, all of these things, but they're very hard to access from this menu. So you want to make sure that you're always making sure your command manager is visible. This is going to save you a lot of time flipping back and forth between techniques. Having said that, about 90% of your time is going to be spent between features and sketch. So really these two should be reversed, actually, but that's not how things work. So this is something that you really want to make sure is enabled in your. You want to make sure that the sketch is the one you go to first. So sketch is what you're doing on 2D planes. Features is how you tie all of those things together with 3D processes. That's the way to think about this. So you perform a feature on a sketch, and the sketch is kind of where we're going to start for today. So mechanically, once we start doing 3D views and other things that require really a mouse are going to be more useful. You can kind of do them halfway with a trackpad, but trackpads are of the devil, so you don't want to use those at all. All right, so what you do to start is simply hit the sketch button. Sometimes because reasons, something will happen where when you go to hit sketch, you won't necessarily get this. Sometimes you have to disengage and re-engage a sketch button because of whatever. So we'll start with a couple basic geometries. For this, a lot of the early stuff, we start with just a top plane. So you pick that one and it'll automatically center the view. And then we start adding a couple sketch elements. So in this case, we're still on the sketch tab. We're going to add something simple like a circle. And so we'll start with the defaults, which will be a center point circle. So they've now, looks like, changed maybe a couple of these menus, but not by much. So all of the ellipse stuff is here under ellipse, which is good, or the slot and then ellipse. There used to be a couple more options in terms of developing arcs and things. The other thing that you're going to want to do is use the escape key, because that's going to deselect whatever tool you had. So to grab a reference point, anytime you see these, you guys won't be able to see it really on the screen very well for whatever device you're on right now, but there'll be a little yellow symbol that has a couple points intersecting. There's a couple things about the cursor that'll tell you information about relativity and reference points. So it's important to understand some of what those are. So right now, this one is just telling me my point is actually at an intersection. So my point is actually at what's called the origin, which is 0, 0, 0. Now, if I take this at an angle, that white line goes away. That white line shows up again, meaning I have a parallel reference point. So there's a lot of information that cursor is going to tell you about points on the curve. So anywhere along an object, you can also add a tangent element or some things that we'll get into with more detail later. But you can start anywhere in the area, and you can even start outside the area. And these, what are called leader lines, these dotted lines, tell you information about, okay, I want something to be parallel in one axis or another axis. And these leader lines will help you to set up something that is now parallel with something else. So you can reference a lot of different points. You can make it not only tangent to the circle, but you can actually make it perpendicular, or in this case, parallel with the origin, and concentric with the circle, or tangent to the circle, or all sorts of things. So there's a lot of properties we'll learn about in 2D sketching. But for now, what we can do is we can start looking at how to use the smart dimension for something. So in this case, I'll do a couple more of these, but I'll do them a little differently. So you can also go back. For sketches, using the undo button is okay. For assemblies, you almost never want to do the undo button, because assemblies, when we learn about them later, we'll touch on this again, really awful bad things happen on assemblies when they have something undone. So assemblies make a real mess. You lose all kinds of progress. You can lose yourself 15 minutes on the CSWA if you make a mistake there and hit the Control Z button by accident. Okay, so I've just grabbed a couple points along the circle. And what I'm going to do is start using what's called Smart Dimension. So this is your friend. Smart Dimension is what's going to tell us how far away something is from some other point. So usually the origin. Almost every time that we're doing a sketch, what we're going to want to do is called make a fully defined sketch. So what that means is I need to know what diameter it is. So you'll notice the color changed from blue to black because now that circle is fully defined. The reason is it knows relative to the origin how far away that circle is, whereas a circle way up here, if I do the same thing, and I say 14, so we need this one to be maybe 15 millimeters, right? Your different units are going to be down here. MMGS is what we're going to be doing like 95% of the time. You can switch to IPS and it'll automatically update dimensions, but you want to be mindful that those dimensions are here and make sure that you're checking what dimension system you're in every time you go to do a drawing, because otherwise that can get you in trouble. So even though we've done this, we can try and say, well, let's define it this way, and it'll give you an error. So the smart dimension is going to tell you, hey, wait a minute, we already know that information. What it needs to be fully defined is it needs to know exactly how far away it is from the origin. So if you did it at an angle like this, that's some of the information. And you said, I want this to be 122. The problem is it still doesn't have enough information. So you still have to reference the origin by at least 2 dimensions. So you can get there this way, or you can get there by what I recommend is, especially for a thing later on that's a horror story that you guys may or may not have heard, called the French curve. You want to try and reference the origin whenever you can, or something that's adjacent to the origin. So if you reference the origin for X and Y and then set one other dimension, you're almost always going to get full definition for something. And that's what's going to give you the information that you need. So I hit escape to release that smart dimension tool. I want to resize this to be 70. And now I can resize that and move it around and get things exactly where I want them. So that's just kind of a quick how to use the actual smart dimension tool. So one of the other things that we're going to do is set the dimensions of these guys. So if that is 100, I'm going to set these to 25 because no particular reason. 25 millimeters. And what this will do is make sure that everything is of a uniform and controlled size. And then we can do a couple cool things. I'll show you another tool. It's a little early to learn this, but trim entities. I usually leave it on trim to closest. There are other options for this, but basically what this is think of it like almost like an eraser, where you're going to erase a part of a curve and a part of a curve. The part that highlights orange is the part you're going to get rid of. So in this case, I could get rid of the inner arch and the outer arch and just leave this part of the object. And now I have, because it's fully defined, I now have a color fill. So that blue-gray color means I've got a fully defined watertight is what it's considered, watertight area. And so that means that it's all connected all the way around and I'm not missing any information. So that scroll wheel is how you can zoom in and out. So that means if I zoom in, zoom in, zoom in, zoom in, these are attached together. They're not actually like in different points and not connected. So that means this is an enclosed area and we can perform operations on it now with ease. So another thing you'll hear me say a lot is stepping into and out of a sketch. You'll see that exit sketch button. So the exit sketch, what that'll do is that will step out of whatever the sketch you're in. You're no longer modifying it. Now, if you wanted to perform operations, something like an extrude, for instance, this is kind of everybody's favorite. So we can go ahead and get to this kind of basic level today. 10 millimeters is perfectly reasonable. What we're trying to do is we're trying to perform an operation. We're trying to perform a feature, one of these operations on a given sketch area. And so maybe this has two different areas that we want to control. So I'll show just a simple extrusion here. We hit the check mark. I already know it's a fully defined sketch. So I already know I'm not going to have issues extruding. We'll get to complications of revolve and some other techniques later, but there's a lot more stuff that goes into this. So what you want to do is you want to make sure that you are paying attention to how these features interact with the sketch that you have. If you go, oh, wait, that was wrong, I need to change that. It actually needs to be 13 millimeters. In this thing over here that's called the part tree, what you're doing is you're going to come in and modify. You can say edit the feature or edit the sketch. These are two very hugely helpful things that you can jump to immediately. Or you can expand this down, select the sketch and say edit the sketch, or edit the sketch plane that the sketch is on. So later on, when we have to make changes to parts, because engineering is all about how to adapt to constantly changing requirements and circumstances, you can always go back in and edit this. So if you select edit, you say, actually, I needed that to be 50 millimeters, not 10. So now we have a 50 millimeter extrusion of our part, right? What about if we have a little bit more of a complex feature and we go, oh, I forgot to do the holes because maybe this is some kind of a mounting plate or something, right? Well, I forgot to do the holes. So this is maybe a thick plate and I need bolt holes at all four corners or something, right? Okay, well, I need to either go here or there to edit the sketch. So now it's going to show you, here's what I was doing, but now you need to come in and add a couple more things. So when you're clicking and holding down that scroll wheel, you're going to get this 3D rotation. So again, this is part of the reasons why you really want to get to a mouse. You can kind of do that with the scroll feature. I think it's holding down like control and then moving the mouse around or something like that on a trackpad. There's kind of a workaround. You can also use, for those of you that aren't using that, you can use this view orientation and you can change and look at previews and say, okay, front plane, back plane, side views, all of these different things. And you can click the scroll wheel to figure out which side of the cube you need to be viewing it from. I always recommend when you're doing a sketch, you want to look straight on. So what you'll do is you'll select this. And in this case, we're going to select that top because that's going back to our original. If you select on the bottom face instead, what that's going to do, if we go over here, this is the bottom face. What that's going to do is that's going to change the direction of some things, and that can mess with you if you're trying to do some specific references and extrude cuts into something. So there's a lot of things that we'll have to learn in terms of fundamentals. But let me check in real quick. Any questions so far before we start adding bolt holes? Because I could leave you guys with, here's how you draw a flower in 2D. today, but I would much rather get you into some of the 3D stuff already and get you excited about it and start getting your mind thinking about how to go from 2D to 3D if we can, because the sooner we can start making that transition, the better you guys will be at this. Okay, I don't see any panicked, worried looks yet. So, I mean, I need to keep going faster, right? So we're back into editing the sketch. If you're ever doubtful and you're not sure which sketch you're on, you can step out of that sketch by hitting exit sketch, which will be here. If you hit sketch again, what that's going to do is that's actually going to add a new sketch. So I'll show you real quick for reference. What that means is now this new sketch relative to the top plane. So the top plane is here. That new sketch is now up on top of this surface. That's useful for some things later, but the problem is if you have to modify this feature too much, you can lose some reference points. So we're going to start learning everything on a sketch needs to be done, if possible, on the fewest number of planes themselves. We'll learn some more about that later, but there's a lot that you can do with that. So that would start a new sketch. We don't want to do that for now because that'll create more confusion than what we need. Anytime you move this around, in order to make sure you know exactly what the references are, you want to go back and reset it to, in this case, our top plane right here. So it'll say top right there. And this will reset us so that we're drawing square relative to the actual surface itself. So we're going to add some more circles to do our bolt holes. And we're going to do that using the same reference point for each of these circles. So now what we need to do is come in, do our smart dimension, tell it exactly how big. We're going to say 15 because we want a 5mm wall thickness. So 25 minus 5mm on each side. 5 and 5 make 10, unless the world's a little worse off after COVID than I thought. And that'll give us a 5mm wall thickness. So good rule of thumb, if you're making stuff, if you want it to be reasonably strong, something like a 4 or 5mm wall thickness is a good minimum, especially if you're doing additive prototyping or additive manufacturing. In the chat real quick, let me know how many of you guys have already gotten to play around like more than once with 3D printing. A few of you. Let's see, 3D in chat if you guys have played around with 3D printing already. Pour me in chat if you haven't yet. Okay. Seat of the pants statistics says we're probably about 70-30 or so. 70 haven't, 30 have, 30% or so. So that's okay. The good news is you'll get a little bit of experience here this semester, but we're going to have to start learning how to think in terms of taking a real object and then taking that from a concept into 3 dimensions. So by using some of these reference points, we can already do some pretty cool stuff. So I'm going to step out of the sketch, and now it's made some assumptions. In this case, it's made some assumptions correctly, but maybe we didn't want it to do that. We actually want to control the volume that it's actually using. And so in this feature, we're going to select which pieces or contours is what it's called, which contours are actually going to be extruded. So it'll default to the whole sketch and make assumptions because it recognizes that it's, as a software, it's had like 100 million different instances of somebody doing an extrusion like this. Probably those are bolt holes and they want them to be through holes. It's a reasonable assumption. So what we can do is we can select regions and we can select contours. So you want to avoid contours for now because reasons. We'll explain more about that later. Trust me, I'm a doctor. So we can select region 1, which is everything here in purple. And if we select one of these regions, we can individually select these areas and they'll change colors. Then when we go to do the extrusion, everything is the way that we had it originally. So if we go back in and we edit that, what we can do is we can delete some of these regions. You can right click and say delete or just clear selections. A lot of times I recommend clearing selections unless there's like 100 things you have to click. You can also, in this particular feature, you can extrude in different directions. So you could extrude backward from the plane or up from the plane. So you have different options and there's different ways that you can do it. Most of the time you're going to do blind or you're going to do up to a surface or something like that. Sometimes you'll want to do a mid plane, and that just means equal from either side of the sketch plane that you're working from. So there's a whole lot that you'll get some experience with in terms of when each of these is the most useful. So for now, I'm going to leave it to the default as a blind extrusion above the level, as in a positive Y direction extrusion from this top plane. So nothing too crazy. I'm going to leave that there. But then your boss comes to you and says, that's great and all, but I actually need another fitting like this, but I need a conduit pipe to go through. And so we're actually going to need this part, but with a through hole, because they're never done making changes, right? So you can still, on that same sketch, make the changes that you need to. So to reset the orientation, make sure I'm doing things correctly. Actually, let me show you why real quick. If you go to make something like a rectangle, especially something exciting like a center point rectangle, when you're doing it at an angle here, it's not always real obvious what the shape is or where its location is. Center point rectangle, you're going to have a little better aim, but if that was an edge or corner rectangle, you might think that this is giving you a big distance here, but actually, when you see here, this may be a different dimension than what you thought. So it gets to be really cantankerous to try and do things at weird angles. So that's why I recommend always come back to reset your sketch to be square with relation to the origin, so that you're going to save yourself seconds and minutes on each of the sketches that you're working on, because over time, that all of those little details are going to be kind of a pain. So if we need another through hole, we're going to add another circle. And so this one's going to be this one's going to need to be a 1¼ inch. So somebody who's good at math, tell me how many millimeters 1¼ inches is. Anybody know? This is a number you should know. Out of all of the numbers, you should remember this number always. How many millimeters to an inch?
25.
25, close.
25.4.
Yeah, 25.4. That 0.4 turns out to matter quite a bit, like as in the difference between a part fitting and a part not fitting. It's that much of a difference. So if you need 1½ inches times 25.4, you can do it here. Or for those of you that are really lazy, which if you're taking an online class, all bets are off, right? In here, when we go to do our smart dimension, you can say, actually, this needs to be 1½ times 25.4 inches. Now, in this case, this dimension has been entered, but it's been entered in a way that for the millimeter scale is incorrect. right? So you can look at this and say 1.5 times 25.4. You can pick inches. The problem is if you enter inches, that's going to be incorrect, right? So what you actually need to do there is if you needed it to be 1.5 inches, you can say 1.5 inches. So 1.5 in, and now it's 1.5 inches. Okay. Then they come back to you and go, actually, it's about a 62.5 millimeter pipe. Well, start with getting the decimal place right. You can type for millimeter, and then this will give you what you're looking for. So the smart dimension is really your friend. You can kind of enter formulas, sort of more or less. If you're trying to include tolerance in something and say 50 millimeters plus 2, meaning 1 millimeter clearance on either side. You could do even this case, 60 millimeter plus 2 millimeter. So 1 millimeter clearance all around. And this would give you your 62. So you can kind of enter formulas. You just want to be mindful of, again, what unit system you're in. So with this part, now you've already gotten to a reasonably sophisticated part, and we've only focused on a really super basic technique. Again, it's going to assume that you're extruding this region. So the assumptions it's making are that you're doing sketch region 1. There are ways that you can do all sorts of things with the extrude and layer these in different sort of levels and layers. So you can do an extrude. So maybe this one is 50 millimeters. Maybe you need to make a specialized adapter for this that's a 50 millimeter thickness, but it needs to be sort of one side. So 25 millimeters, then you need to take those same geometries and make this some kind of stackable, extendable piece, almost like Lego bricks or something, right? They make a design change on you again. So what you can do is you can come back in and you can say extrude base boss. Once you've already extruded the only sketches that you have, it's going to say, I don't know what you mean. So you have to expand the part tree and then go back in. So up here under the part tree, you find your sketch again. And now you're going to select the contour. So instead of sketch 1, you're going to delete that. And you're going to say, now I actually need to extrude this region, this region, this region, and this region, and this one. I need to extrude those. But instead of extruding those by 25 millimeters, I'm going to go ahead and set it to 25. But instead of just being a blind sketch from this surface down here, we're going to change to being from a surface here. So, or you can keep it as blind and you can say from a surface here instead of with an offset. There's 2 different ways to do this easily. You can technically use a vertex. You would pick a point up here, but there's no really nicely defined point because the sketch is down below. You can maybe use this intersection point, and that would extrude this piece up above this level. It's a whole lot easier most of the time if you can to use the surface or face plane. So you select this window and you select from this upper surface and then still blind 25 millimeters and you hit OK. So now what we have is a stackable part, right? Almost like a Lego brick or some kind of, alignment dowels on some kind of a machining part or a stand. Lots of different kinds of things that you can do this with. But you can actually do this at a lot of different levels, and you could do the same sketch. You can do an operation on that sketch at a few different levels. So you could do one more here again from sketch one, and you could do a couple of these in a row just to show what that might look like. Or maybe you need a coupler to go from one to another. Maybe you need a male to male coupler, female to female coupler. Yes, that's still what those things are called. Just is what it is. So from the sketch plane, instead, you're going to do from the surface again. And in this case, it's selected the correct sketch region so that we can go back and forth. And so what that does is that allows you to now create a reasonably complicated part. And we've only used really, truly a couple of the sketch features, and we've already created something pretty cool. So the idea here is to think in terms of each of the dimensions as you're going up. You're doing something that's based on this two-dimensional sketch that we started with, right? So going back to that centered view here, that 2D sketch is the same thing that we started with, but we've now created a complex piece from that same sketch. So you can do a lot of operations on the same sketch. And here again, this is something that's going to save you a lot of time later rather than coming in, doing a new sketch each time for every single individual hole. Then if somebody comes in and says, oh, you know what? Now that you've built it, our guys mismeasured, and actually all of these bolt holes need to be 12 millimeter because otherwise our tolerances are all going to be off. Then what are you going to do? If you have to go edit individual sketches the whole way along, you're probably going to cry. Instead, you come back here, edit that first sketch, and you set it to be 12 millimeter. So same with this one, 12 millimeter. Same with this one, 12 millimeter. Same with this one, 12 millimeter. So now when we exit the sketch, no big deal. We were able to make changes to our part very quickly, right? So some of the stuff we've learned has already taken us to some of these components, right? Drawings, details, sketch elements, editing parts, right? That's not quite an assembly, but we're learning about faces, smart dimensions, lines and center lines, circles and arcs already. So all of these things are immediately and directly relevant to the stuff that you guys are going to be doing. So I want to give you guys a few minutes to kind of catch up to some of this design. I'll go back to the sketch dimensions so that you can see what's going on. But I want to see if there's any questions at this point before we start getting into some other features like some of the rectangles and other sketch elements, because we're going to come up really, really fast. It might even be next week on the French curve. So how many of you guys have looked at the French curve already? How many of you even knew there was a French curve assignment? That's also a good question. We'll take a look real quick, just because in case you think I'm drowning you guys with a fire hose because it's entertaining. Let me pull up the assignment. Let me pull it up real quick because I think it has a new attachment this semester, which is actually a whole lot better. So I'll pause on the screen share for a second and I'll pull that up because you can access it from your calendar. There'll be a couple other things you guys will see. Let's see why they don't default to all weeks on that view. I couldn't tell you, but it is what it is. Let's see. There we go. Yeah, next week is correct. So this is why you guys probably think we're trying to cruise in like 87th gear, like this is some Fast and the Furious movie where the transmission has 8 million speeds. But there's actually a reason why we're going so fast today. And this is it. So the French curve, this is one that is infamous. Believe it or not, it has been refined, but this is the thing you're actually going to be doing. And this is the thing we're going to be doing next week. So we're trying to make sure that you guys have all of the pieces you need to understand what some of this gibberish is, because you've already seen today the smart dimensions. You've already seen you haven't seen the arcs to the same degree yet. We replaced the spline on this with a couple pieces of arc, which is going to make your life infinitely easier trying to get to the end state. So now we're going to take a look at how to kind of redesign this part a little bit with maybe we'll start with a new design that'll help us to understand what some of these angle measurements are and how to get to those. Because you've seen how to make the measurements for side to side like this and measurements relative to the origin, which in this case is here. So the height of something relative to the origin and the distance of something else relative to the origin is really, really important for getting this kind of a sketch fully defined. So actually having used a couple of these arcs and redefining the measurements, this should shave probably a couple hours off of this assignment easily. So the good news is you guys have a lot to catch up on. Or maybe the bad news for you, the good news is we can get there pretty quickly by applying some of the techniques that we have. So this seems a little bit scary, but it's really not all that bad. Another thing to note is these A and B trips up a ton of students every semester, so pay careful attention. Detail A scaled at 2:1 so that you can see it more easily. This shape is what's encompassed in, this is actually the detail right here for B. So this should actually be labeled as detail for B. This should be labeled as detail for A. Yeah, okay, it looks like they're down below. So detail for B. So this arc, it's giving you some additional dimensions. So those are things that are going to be really important, because when you change something from a circle to an arc, you start changing a couple more things. So let's take a look at that, because that's all going to be important for what you're doing. So as much as you guys thought I was just rambling because I like hearing myself talk, we're going to start with another part. So we're going to go to new, start another part, and we're going to start with another sketch. So what this one's going to do, we'll do top plane again, just to keep things simple, top down view, like you're drawing on a piece of paper, right? If we're going to create in this case, we'll start using a couple rectangles just because it'll give us some additional experience with some of these other tools. There's a couple ways that you can use these arcs. So you can create an arc out of a circle. It's kind of a little easier to define an arc intentionally this way. You have a couple different types. Center point arcs give you some things that are pretty useful. We'll show you what a tangent arc does naturally. A tangent arc is going to make this more of a slot type geometry. You really can't do as much simple adjustment for a tangent arc as you can for some of the other two. So a 3-point arc or a center point arc. 3-point arc sounds very much like what it is, and it'll give you a reference point. So 1, 2, and then 3. So 1, 2 is the end points down here. 3 is the point at which it's going to be connected. So often it's going to make some incorrect assumptions. We'll learn later how to make good use of these. But a 3-point arc allows you to get a specific type of geometry, kind of like what you saw there on the on that French curve. I'm not saying you start that with a rectangle because that would actually be a tremendous mistake. But the easiest type probably to use is actually a center point arc. So if you start a center point arc, it's helpful to find the center point, which will be denoted on any line with this kind of diagonal double dash. So center point and this yellow figure will tell you that this is concentric with that point. And then you find just like the drawing represents, 1, 2 is the start of your arc, and then 3 is where it ends. So you could start your arc out here if you wanted to. And if you're very careful, sometimes you kind of have to zoom in. So again, this is why I'm recommending get yourself a mouse as quickly as possible. I'll start it here for the sake of simplicity. So that double circle means concentric. A lot of times, if you're just trying to do the arc segment from here to here, maybe 90 degrees or something, a lot of times what you'll have to do is whip your mouse all the way around and around again to get it to give you the specific arc segment that you're looking for. And then you can play around with some of the definitions. So you can tell it what's the radius of this. Maybe it needs to be, in this case, maybe it needs to be 35 or something, right? Now that's going to dissociate. That's going to change the dimensions of our rectangle because we haven't set the rectangle, but it's referenced relative to the center point of this specific line. So we use smart dimension to be able to tell something about how far this needs to be from the origin. Maybe this only needs to be 50. And maybe this needs to be 75. Okay, so now the rectangle piece is fully defined, and I need to define on an arc, you're going to get a radius. So anytime you have a segment of a circle, it's automatically going to become an arc, and it's going to give you the option for radius. And so that's what the R indicates on those dimensions. So radius of such and so. And especially if you see a leader line for a dimension that's way off the sketch somewhere, that's probably a good indication that it's a tangent arc, or it's actually a 3-point arc rather than a tangent or a center point arc. It could be you can redefine those things, and we'll look later in 2D sketches about how to break some of these relationships. But it's a lot of things. So the downside of you guys having Monday off last week means we have to cram literally 2 weeks of content into one part of a class. So that's why I'm hoping you guys will get a chance to go back and learn a lot of this. So a lot of useful things I think will come out of this. Okay, so you can also set relative to the origin how far away this is in terms of X and Y. In this case, since we've already defined it, it'll give you a yellow warning saying, hey, this is a problem, because we've already defined our rectangle. But what if we go back in time and we say we don't have a rectangle there and we need some of those same geometries? Well, you can still do this by adding, especially something like a 3-point arc. You can do that using these leader lines and saying, okay, this I need to be parallel, and this leader line going up, I need to be parallel. And now I need to set kind of the radius of this arch. So I need to start somewhere. I can use something like a smart dimension to get a distance between this. And so maybe this is 100. Maybe this is 25. And then I need another arc segment. So I'll set some definitions for how to get this fully defined, but I'm going to do that by connecting other arc segments. So we'll do another 3-point arc out here. So I'll start this down below. Maybe this will be connected to one. I'm going to use this leader line for my horizontal reference. And this one's going to be dimensioned in such a way as to be maybe 3 below or 2 below. Yeah. 3 millimeters below. And sometimes you have to grab that smart dimension tool again. It'll get a little confused. So you have to tell it that point to that point. Maybe that only needs to be 75. Okay. A couple of the points that I'm going to work on to make a connection here is I'm going to do another 3-point arc. So I'll do it in 2 pieces. So this one, for the sake of simplicity, I'm going to set a reference that is horizontal so that I have some common points. And then I'm going to do another 3-point arc connecting this one to this one. And it's going to bow in slightly the other direction, something like that. And then what this will do is this will allow me to set a couple of the things that are needed, like, for instance, what's the height of this point relative to this axis, which is going to be the Z. So you're drawing in the XZ plane for this one. So maybe that only needs to be 65. And maybe this needs to be 65 also. So those are parallel. And maybe this radius actually needs to be 45. So now this one's fully defined. This radius maybe needs to be 130. Okay. And this point now needs a reference to the other axis in order for it to be fully defined. Maybe that needs to be 125. And this arc needs to have a radius of 335. And then you'll notice that this reference point stays. This one has to shift to accommodate that. This radius, maybe that only needs to be 12. So we've got a couple more things that are fully defined. This one, we still need one more key dimension. And that might be something like 2. So now we have all of these pieces of this arc fully dimensioned. And then we need to close up this bottom piece with some more arc segments. So a lot of times, again, the 3-point arc is going to be your friend for a design like that. So here, maybe we've got something that actually intersects the origin. Maybe that comes back in sharply. And then we have one more that we're going to use to connect this. So let's see, something like this. All right, so now getting our final smart dimensions, we have a radius of, let's say, 105. We have a radius for this one of, say, 55. And then we still have an undefined point here. So we know that this point is referencing this one, but we don't know how far below this point. This is one of the ways to check if it's missing that dimension versus if I tried to define it down below using the smart dimension, what it's going to do is it's going to tell me, I already know this. That's not really helpful. In this case, because we hadn't defined the distance between this point and this point is 0, a lot of times that's going to overdefine your sketch. So in that specific instance, it didn't. But generally, if you have references in one axis, you need to grab a reference in the other axis. So something like 17. And now we've got everything fully defined, right? So you can make a pretty wild shape out of just arc segments and fully define it by telling it where the endpoints are and all of those sorts of things. So this is what I mean by that kind of sketch, where you have all of these different reference points, you have different radii, you have different spacing and start points for arcs, you have different kinds of arcs being used. But most of this is going to be arc segments that you're going to have to look at a little more closely, especially paying attention to some of these detail pieces. So technically, you've already got the information that you need to know really to be able to do this, with the exception of the angle at which something is sitting. So we're going to look at some of those things next, so that you guys have at least seen that piece of it, right? So I'm not going to show you exactly how to do everything on that sketch, but you can get there using the principles that are here. So when you're adding something like a slot, you can add a couple different variations of this. The easiest is the 2 endpoints and the radius. So you come in here and add a slot, pretty straightforward. What you can do is you can add what's called a center line. So we haven't used a lot of line tools yet, but the center line is going to be really, really useful for you guys. There's a lot that goes into this. But a center line is going to be really useful as a reference point. So a lot of times what you want to do is drag it somewhere out here where it's not actually touching one of your other center points. It can be parallel to, but you want to drag it out so that it's parallel. And what you'll see is sometimes you'll have an intersecting point and parallel, and that's an okay reference to have. The center line, because we've run that through a point that was already fully defined, it becomes itself fully defined instead of staying blue. The reason you want a center line is for this next part of the feature. So if we look at it and we say, I want to look at the angle between two things, instead of looking here at just the width dimension, if you also select somewhere in the middle of a center line, you can get an angle between those things. But in this case, because they're already defined as perpendicular, you're going to get a perpendicular distance. So there's a couple ways that you can get around that. One of them is you can come up here to another tool. So this is, again, showing you guys stuff that sometimes would come in week 2 or 3 or something. But the entity that we're going to rotate is this whole slot. And we're going to pick a center of rotation. So we'll show another example where you'll be able to see the angle measurement between 2 lines. So this center of rotation, you probably want it to be one end of the slot, and then you can move it up and down a few different degrees. But in this case, what you want to do is typically you want to grab it and you want to rotate it around the center point. And what you'll be able to do is you'll be able to grab that arrow and rotate it and specify an angle. So you'll have to come in here and say, actually, I need this to be, whatever it is, 345 degrees. And that will give you, once we've got this rotated, you can actually see an angle measurement by grabbing one line and then a center line. Now it tells you the number of degrees of separation. So you have to click not on the center line or on the center point, but somewhere on the actual line itself. And you can say, okay, actually, this needs to be 17 degrees, and it'll make adjustments. So then you can use the origin as a reference point and say, oh, yeah, this was supposed to be 52. And this was supposed to be, let's see, this was supposed to be 95. Whoops, missed it. Now you can set the dimensions of the actual part itself. So radius, maybe it's supposed to be exactly 25.4 millimeters. And maybe that separation. So for instance, if you grab that center point and then anywhere on that line, you're never going to get an angle distance. You're always going to get a perpendicular distance. So maybe that needs to be 12. All right. So now we have something at an angle that's fully defined because of its references back to the origin, right? So there's a lot of things that you guys can do with these angle references, but you got to be careful about how you use them and what's anchored where, what the center of rotation is, all of those sorts of things. So before we get too much farther, we'll pause here again for a second. Any questions or points that you guys are like, whoa, that was way too fast, go back and do that again? This is part of why there's going to be recordings of this. 2 weeks of content in a single day is brutal. The good news is some of you statistically will survive. So that should be encouraging. Any points that you're just like, whoa, I missed that whole thing? Because if you don't communicate, I won't get all of that information. Hopefully, by being able to go back through the recording and play it multiple times, there's a lot of times students will go back, play stuff 5, 6 different times to get the pieces they need. Since I don't have, like a full-time lackey to do all the editing and timestamps and stuff, there won't be that level of scrubability to the video. But yeah, hopefully the recording will save lives. There's a lot of stuff that we're trying to get through in terms of mechanics of sketches and using some of the sketch tools. So we've really only covered not even a whole lot about lines and center lines, but let's look at how those are useful. Any other questions? I'll try and keep an eye out as we're going for any additional questions, but what I'll do is I'll start another one so that we can see an example of where center lines are really, really useful. Because there's a couple more techniques that are also going to save a lot of time and get you guys some efficiency before you go to do those testing. So we'll start again with top plane. This will be one more kind of really, really good thing to have. Let me see real quick what other pieces you guys have currently, because I'm going to do some updates to the calendar, but there's going to be a lot. There's a lot of stuff coming. So there's a ton of tutorials you guys are going to be working on. You're going to be getting into parts and extrusions. So we've kind of covered some of those things. I think they do a little bit of filleting. You'll get farther into fillets a little bit later, but the French curve, so we've got some of the fundamentals down for that. Some of the pattern features, some of the patterns Yeah, so let's take a look a little bit into some of that as well. Pattern features are really going to help a lot in terms of saving time. Won't necessarily make life a ton easier, but it will if you're trying to do something repeated. So we'll do a quick example of how to make something like the head for a fly swatter, which sounds pretty advanced for something that happens on day one, but since this is actually really day two, we have a lot to catch up on. So um, we'll make use of another fun tool on this one. That'll be a polygon. So we're going to set our smart dimensions. How big do you guys think the average fly swatter is in terms of dimensions? What do you guys think? What's the head of a fly swatter? I mean, 6 by 8 would be a serious fly swatter. That would be impressive. You could fly, you could swat some serious flies with that. But this is also part of what we're trying to get a grasp on in this class is how to draw something that's relative to real life. You need to start understanding some real dimensions. Just wait till you get some part drawings and you guys get to start working from those because we're going to start drilling and drilling and drilling on those pretty frequently, I think. So yeah, closer to maybe about 3 by 4 inches is going to be a little bit more accurate. So you can kind of cheat and say this side's probably actually going to be closer to about 3.5 inches. And then this side is going to be maybe about 3 inches, right? So that's probably more or less the profile. Then we're going to use a couple of lines so that we can use that one of the other tools. Again, we have our concentric reference here. So we're going to come somewhere down here. We're going to click, and the line tool is going to give you a few different connection points. Then it's going to try and continue and make lines all day long. And everywhere you click, it's going to try and do things. So you use the escape tool to get out of that line tool, and that'll save you more time, effort, and energy. What you can do for lines is same kind of idea. You can specify an angle here on either side. So we'll specify an angle on one side and say we want it to be approximately 55 degrees because reasons. This one we could reference to this angle, and what do we want that to be? If we want this to be symmetrical, what do we want that to be? How many degrees? Anyone know? I mean, should be at least maybe 145 or something, right? Any ideas? Anyone daring enough to hazard a guess? If you want it to be perpendicular to the other one, how many degrees does it have to be? You only have one choice. Except when 180 degrees actually becomes not 180 degrees. And then, even though that seems like that should be correct, that is 90 degrees with respect to this. Is it actually ever going to be 90 degrees with respect to the 55? Nope. So what we'll do, if you don't know, is you go, maybe I can set this to be 55. And then I can figure out what the angle needs to be. Because if you don't know, spending more time on it is not necessarily going to help you. Now we can look at the angle between those two. Okay. The correct answer is 110 degrees. So super not obvious, right? So make sure that when you are referencing a dimension, you understand exactly how far it needs to be. So this might be another about 1.25 inches in total length. And that probably looks to be correct for the ratio of a fly swatter. All right. So we have an enclosed area. We have a non-enclosed area. This is technically a separate area. What we can do is then start using our pattern, but we're going to need a reference point. So instead of making more lines, we're going to use center lines. So what center lines do is they give us the ability to do some pretty cool things. So in this case, if this is 3 inches wide, then maybe we want about 1/4 inch spacing between center lines. What we can do is a couple cute things. Some of you won't think SolidWorks is cute after today, but that's okay. You could say 0.25 inch. So we're pretty close to there. You can do a pattern. So it's called a linear sketch pattern. So there's a couple different variations. You'll use the circular sketch pattern in the tutorial. We're going to look quickly at this one. What we're actually trying to pattern is this center line, and we want 1/4 inch spacing. So 0.25 inch spacing. And we want to make sure we have the right number of copies. So you can keep adding these until you get all the way across. So 11 total entities. Now we have 11 copies of the center line. Okay. But we don't even have to do this because we can copy this whole group of things. What we can do is we can undo that linear pattern. We can do another center line here. And a center line is going to give us a reference point that's an intersection, which we can use as the center point for something else. So again, smart dimension, we're going to say, so this would be what's called a 1/4 inch pitch. So 1/4 inch by 1/4 inch. So what we now need is one of these entities at this intersection. Okay. So at the intersection of those lines. And we're going to make this a, you can make it multiple points, but the easiest is going to be to use a smart dimension and say, I want each of these to be, maybe right at about 4 millimeters. Then you can use your linear sketch pattern to create what's called an array of these particular objects. So we're going to select this whole thing, only we're not going to create any in the x-axis. I'm going to create all of these in we're going to leave it as 1 in the x-axis. We're going to leave this as a starting point of maybe 10 in the y-axis and switch direction. And 10 is 1 too many, so we're going to do 9. So 9, and we need the spacing to be 0.25 inch. So now we can go up in our number until we reach our goal, which is going to be about there. And then maybe we'll do 13. just because uneven numbers like that are said to be lucky. Okay. Now we have these entities. So what we can do is we can do one more sketch pattern and we can pick these entities. So we zoom back in, we select all of them, and you can very quickly see why something like a Chromebook is not going to give you that last one. You want to make sure you've got the entire entity, not just one of the lines, because otherwise bad things happen. So now we can replicate those at a spacing of 0.25 inch. And we can say however many we want. So in that case, that's going to be one too many. All right, there we go. We hit OK. Now we have all of our pattern in place. We can do it in 2 axes and we can step out of the sketch. We can go back over to our features, do an extrude, and we can pick this region and this region and do 2 millimeters. And now we have, if we hide the actual sketch itself using the eyeball, we can look at our fly swatter pattern, right? So you can do a lot of really, really cool things really quickly with that kind of pattern, so long as you know what you're doing. The circular pattern works similarly, and you'll see an example of how to do that in the tutorial. So I don't want to duplicate that effort, but I want you guys to start seeing some of the things that you can do with these sketches. So you have a lot of flexibility in terms of what you can actually accomplish. So that way you can start thinking in terms of, okay, how do I do this? How do I start making things that are realistic? And one of the challenges that I would issue to you guys is, aside from what feels like a crushing overburden of work that you already have for the semester, try and see if you can figure out how you would draw more and more and more stuff that's around you. As you go through this semester, we're going to get into more and more and more practical and very real examples of what this looks like in terms of additional geometries and things. But there's a lot of techniques that we have to kind of get through up front. So the first part of this class is really heavy in terms of me demonstrating content, demonstrating techniques. A lot of the back half of this class is you guys putting this into practice, trying it, figuring out how to make it work, figuring out how to get the reference points right, figuring out how to use the smart dimensions to your advantage. And along the way, I'm going to continue to show you guys time-saving techniques on, you might look at a part and say, oh, it makes sense to me to build it this way, right? And maybe that's okay. Maybe it makes sense to do some other things as well. I'm going to look and see if I have another example of a simple part so that we can start kind of getting a sense of what that looks like. Actually, maybe I'll just draw inspiration from what I've got here. So a couple of you are coffee drinkers, I can see. Anybody like super hardcore on green tea and won't touch coffee if their life depends on it? Yeah, a couple of you. A couple of you already strung out on Monsters and Red Bull, or did you dare to drink the Purple Lopes energy drink? Curious to know what preferential range of caffeination choices you guys are using. Anybody been subjected to GCBC coffee yet? A couple of you. I'm sorry. The good news is taste buds can grow back. Yeah, just make sure that it's not the sugar-free Rockstar, because the sugar-free Rockstar, I pulled up the MSDS sheets for that one, and no less than 17 of the ingredients on the sugar-free Rockstar have to be classified as hazardous waste for disposal purposes. I kid you not, it was legitimately 17 of those ingredients. So it's supplements. It's all fine. We'll ignore the rat sterilization studies that they found with some of those chemicals. Whoops. Yeah, so choose carefully. Just saying, looking out for you guys. You might have less liver cancer after taking this class. Who knows? So I'm going to pull up another example of another part. I have, let's see. I think there were some good ones here. Let's see. There should be some more examples. Did I ever get drawings of these? Yes, I did. Okay. So one of the things you'll do later in the semester is you will do you'll do some pretty complicated variations of things. You'll do some pretty complicated versions of um, an assembly where you're going to do a four-wheel drive car and you're actually going to print them out. I'll bring that prop for you guys to see probably for the next class, so that you can be thinking forward into what's going to be involved. But one of the things you're going to have to do is draw some of these. So this one isn't quite the one I was thinking of. I was thinking of the 36 and 12. So a simple, relatively simple gear is something that feels like it's going to be immensely complicated, but it's actually something that you guys are going to start to understand that as kind of we go along. It's not actually that bad. So we won't draw this one today, but I'm just getting you guys to think in terms of you'll learn how to actually start designing and making some of these parts, because it will be ultimately useful to you for a lot of reasons. So let's go do one more. And in this case, we're going to do the coffee mug example because that's a really, really good one. So let's start from scratch with this, and this will demo another example of this technique. So let's see a vote in the chat. Do you guys want to do a normal old school, like world's best dad ceramic mug, or do you want to do a simple travel mug? What one do you guys prefer? Because there's pros and cons to both. We'll show you another way to use the extrude. All right. Right now, old school mug is in the lead by a long shot. This is usually something that your first day into class, you guys probably don't think you can actually do, but all right, I think I've seen enough votes. So we're way ahead for world's best dad mug. Okay, so here's what we're gonna do. We're gonna start another sketch, and this time we're gonna just stick to extrude and keep stuff simple. We're not gonna get into the fancy revolves and stuff yet. We'll see later how to kind of elevate this technique. But yeah, I think that one's unanimous. All right, so world's best dad mug. All right, so here we go. We're going to start with, again, from a top plane, because we're going to start thinking in terms of if you're going to replicate something in 3 dimensions. One of the things I want you guys to think about is this. What we're focused on is we're focused on when you see something, there's going to be a level of symmetry. And so instead of trying to draw the mug this way, what we want to do is recognize that this view, this top-down view, is a circle, and we know what that geometry is. So we can do a lot of things quickly by extruding a circle rather than trying to draw something this way and then cut away material until we sort of make it round. That can work, but it's a mess. Don't do that. So instead, do it a better way, which is what I'm going to show you. Okay, so what we're going to have is we're going to start with a base circle. So the real question is, what's the outer diameter of a world's best dad mug? Right? I'm sure a couple of you are already chat GPTing that. I don't actually know if chat GPT has the answer because mugs are all different. But what do you guys think? 4 inches? That could be. A lot of those specialty printed mugs are probably in the 4 inch range, actually. 2.5 inch. That's getting down closer to one of those like European espresso cups. That's kind of like a bad joke. So that's not something that you put enough caffeine in to keep a human alive, at least not a college student. So for this one, we're going to start with 3.75 inches, even though we're still in the millimeter, meter, gram, second. We're going to use this as our base. So about 3.5 inches, and then we're going to have an interior dimension. So we know we're going to need, we know that almost all world's best dad mugs have some kind of a ring on the bottom, right? Because that's how it leaves coffee stains. So we got to have some kind of a ring on the bottom. Okay. And then we're going to have an interior. For now, we're going to assume that those two things are the same dimension. So what we can do is instead of specifying the radius, we can actually do it this way and specify the difference between the radii to be, we're going to say that's about 4 millimeters. So 4 millimeters probably about right for that coffee ring, right? Aspect ratio probably looks pretty good there. Okay, so we're going to do a couple different things from this sketch. We're going to go back up to features, and we're going to extrude this. We're going to go up. And so the next question is, can ChatGPT tell us what height our mug actually needs to be, right? What's the actual height of a world's best dad mug? What do we think the height is? There's 3.5 inches. It's probably not too far. Usually, coffee mugs are made with approximately square dimensions. So they're usually going to be roughly similar diameter to height ratio, unless they're like a little bitty teacup, and then they're going to be all kinds of crazy dimensions. So this one, probably actually going to be right in the ballpark of about 90. So 95.25 outer diameter and 90 millimeter height. So now it's already assumed that we have a dimension, but right now all the coffee would pour out of our world's best dad mug, right? So we got to fix that. Okay. Well, there's a couple things that we have to do, right? One of them is we're going to need to do another extrusion from the bottom. So we're going to go back to extrude base boss. We're going to go back and select the sketch that we're interested in to perform that feature on. And this one, we're going to go about, we're going to go about 8 millimeters. It's always heavier at the bottom. And we're going to select, instead of, we're going to clear selections and pick only the interior region, which is going to bring this up like this, right? So we're imagining this is going to extrude this thickness, because what we then need to do is inside a World's Best Dad mug, there's never like really sharp corners, right? It's always some kind of like a casting, and there's a kind of a cutout of some sort here. So we're going to do a really simplified version of that. So this is going to be, we'll learn some techniques to do this later, but the opposite of an extrude is an extrude cut. And so what we're going to do is we're going to take this sketch, we're going to do an extrude cut of, we're going to clear selections, we're going to do an extrude cut of this. We're going to switch directions going up into the base. And then what we're going to do is we're actually going to do what's called a taper. So we're going to taper this by, we're going to increase this. So if it's something like 45 degrees, we only want to go about 1 millimeter up. That taper is going to look like this, 45 degrees. So we're going to have to increase that to about something like about 85 degrees. It's probably more reasonable. So what this will do is this will do a simplified cut 1 millimeter up. And this will give us that indentation on the bottom by doing that tapered cut. So you can also do tapered extrudes, but this is a tapered cut. So that'll give us our coffee ring maker at the bottom, because that's essential for any World's Best Dad mug, right? Then on the inside, what we're going to do is, since they're never square, what we're going to do is called a fillet. So there's two options. There's a fillet, which is rounded, and a chamfer. We're going to do a fillet. It's going to show you a preview with a 10 millimeter radius. Nope, not even close. But typically somewhere around 1 millimeter radius is a little bit more accurate. So some cases, some mugs might be closer to about 2, but that's about your limit for the fillet. So you're going to see this technique also used in that tutorial. So this is where to practically use that. So maybe that's about right. Inside. So same deal, that outside edge, we're going to apply the same kind of tool to. So we're going to do a fillet. This one's probably almost always going to be about a 1 millimeter fillet. So it's not going to be very much, but just enough, right? Because there's almost always kind of a smooth edge there. Same thing with the top side. We're going to do that. We're going to do our fillet at 1 millimeter. And we're going to do that on the inside again with 1 millimeter. All right. So then we're going to need a handle of some sort on our World's Best Dad mug, right? Otherwise, it won't be a World's Best Dad mug. So what we're going to do is we're going to need to take advantage of, this was kind of the whole reason I chose this example. We're going to add a plane, but we're not going to add from here, because this is a plane into the 3D sketch, does bad things. What you want is a reference geometry. Under view toolbars, reference geometry, I recommend pinning this to one side, because you're going to want things like axes, planes, points, coordinate systems. center of mass stuff for later. So it'll make life a whole lot easier. But what we're doing is going to tools, and reference geometry. So it's in a couple different places in here. Here it's not listed. It's under relations. Where is it at in the toolbar? Yeah, it should be in under the features. So insert reference geometry is where this one is. So if you can't find it anywhere else, you can always come back here to find it, but spending 3 minutes remembering where something was is a whole lot harder than just adding the stupid toolbar where you need it. Reference geometries, 3 points define a plane. Really, really important. If you have something already defined, that's helpful. In this case, for a circle, we could define it based on a base and then set an offset or a distance from that object, but that's not helpful. So if you try and set a reference plane based on a surface, it's going to kind of guess that you want it to be tangent, except that in this case, we want to try and extrude it to the side. So we really don't want it to be tangent in that way. Later, we'll learn how to do this with a sweep, but we're not going to do that right now. So we actually don't want to reference that face at all. What we want to do is we want to reference a perpendicular plane, because if you reference one of the perpendicular planes, you're always going to get essentially what you're looking for. So here, about a 10 millimeter offset from the front plane is going to be good, because we want to extrude a handle from one side to the other. So what we're going to do is we're going to sketch this. Again, I'm going to reset to the front, so the front plane here, so that everything is square. 10 millimeter offset's totally fine. We're probably going to do in total about a, actually we'll do, maybe we'll do about a 16 millimeter extrusion. Half of that would be about 8 millimeters. So you'll see why in a little bit. So you can drag the corners of that plane out farther, and we're going to make the handle on this side. So this plane is now where we're going to add a sketch. But instead of just going to sketch and adding, or going to the sketch window and adding a sketch and hoping it's in the right place, it's best practice to right click the plane and hit the sketch with a star. So that's going to add a new sketch that's on that plane specifically. If you don't, you can end up with some headaches. So this again falls under the category of trust me, I'm a doctor. So we're going to need some kind of rectangle. We'll look at one more kind of feature. I'm going to start this just to the very inside of this. And I'm going to do the same down here. Keep that relatively simple and straightforward. And then I'm going to connect these this way with rectangles to keep things a little bit simple. I'm going to change a couple of those dimensions, but what I'm going to do is change them with a sketch dimension. So you want to make sure that this height approximately is a minimum thickness. In this case, it's probably going to be closer to about 5 millimeters. So for each of these sections, it's probably going to be closer to about 5 millimeters. And you want to keep that in mind. So 5 millimeters for all of those sections. And then what we can actually do is we can use a combination of tools that we've seen from earlier today. We're going to use our trim tool to get rid of a couple pieces that we don't want, which is the two ends of that rectangle and then the two ends here. So now you have one continuous defined region. Okay. Now what we're going to have is we're going to use what's called a sketch fillet. So you can pick these corners. We'll start with the inside ones Again, you probably want something like a 5 millimeter radius. So you start with the insides, then we're going to do it to the outsides as well. Okay, make sure I've got those two. So you can kind of pick, you kind of have to select the three entities that go together there in order to get that radius. This one might be more like a 6 millimeter radius, or maybe even an 8 millimeter radius. A lot of times, if you have an inner and an outer that are the same dimension, your radius is going to have to end up being 2x for it to look, quote, correct, meaning that thickness is going to stay the same because of just a mathematical reality of the geometry. So we'll come back to more examples where we're using that specific tool and cut away those two remaining line segments. All right. Now we have our features all set up. We can do an extrude on this. We're going to go the opposite direction. We're going to do 16 millimeter. And that's going to be sized almost proportionally to our cup. And we're going to be right about there, right? We might decide, that's a little too narrow. World's best dad, probably going to have bigger hands than that. What you can do is come in, edit that sketch when your boss makes changes. And believe me, your boss will make a lot of changes. So maybe this actually needs to be about 15. And the distance, so this one also needs to be, I'm going to deselect that point. This also needs to be about 15. Okay, so that kicks it out just a little bit. Maybe it even needs to be 20. That's probably more correct. And this is why we make adjustments. So now we step out of the sketch and it'll redo our three-dimensional object. So now we don't have any weird clipping inside of the cup. We'll learn how to do that a little more cleanly later, but there you have it, a basic start to a coffee mug. And you can clean up the edges using the same sort of technique. Fillet of about maybe a 2 millimeter radius, and you fillet that side and this side, and then that edge and this edge right here. So sometimes you can get away with a fillet. If you make it a 3 millimeter fillet, it will connect them, assuming it doesn't give you an error. And what that'll do is make those all smooth and one sort of semi-fluid connection between the curves. All right. So there's another quick example of how to, just using 2D sketches, adding in one more element of a reference plane, you can create these kinds of geometries in order to start already getting to some really basic representations of a three-dimensional object in just a handful of minutes, right? How many of you thought you were going to die before that example ended? Nobody? Okay. It's all right. You can be honest. There's a lot of stuff that we have to try and jam into this first session. So there's a lot of moving pieces that we need to have in order to make all this work. So there's some good reasons. But I wanted to make sure you guys had an opportunity to actually work with this and see some examples. So I'm going to pause for a second again and kind of open it up to questions. What questions do you guys have on some of these techniques? What things are you not sure, like, hey, when are we actually going to use this? All of those sorts of things. because you've already got some pretty reasonable examples of how this works. But I'm curious for a second to see what kind of what your questions are, because there's going to be a lot of going back and starting to recreate stuff, come up with questions. Wait, what did he do for this? Stuff like that. There's going to be some instances too where you'll be able to look through the videos and go, oh, okay, that's what he was clicking. So that's why I'm trying to capture all of the pieces of this so that you guys have a fighting chance of being able to actually take some of these techniques and turn it into something. Yes, so there are a couple things. There are a couple things that you'll have to do. So, especially if you're running on a trackpad, you accidentally do something like this, and then you move, or maybe you used control and the scroll wheel at the same time, moves you way away from something. Your best friend is going to be this key. So instead of F's in chat, F is for zooming in for finding whatever your object is. So you can also hit spacebar and go back to the view. So that might be a hotkey that you guys want to remember, especially if you're working on a trackpad for now. This is some of all of that little detail that we're going to cover. Some of that you're going to miss some little bits and pieces like that. So you'll want to pay attention for that. So there's a lot of um, a lot of aspects of this drawing system that you're going to want to learn, but you're going to have to do some additional study. I think there are a couple of keyboard shortcuts. I don't remember them offhand. I'm sure somebody out there has created an extensive list. But there are definitely some keyboard shortcuts. So they have a lot of those for some of the other softwares. This one is more set up to be, this is kind of what Fusion 360 is starting to chase now in terms of kind of some of the mechanics, some of the tools, etc. There's a lot of different CAD softwares out there, but instead of being very text editor heavy like traditional AutoCAD and Autodesk is, this is meant to be a little more user friendly, which is a little bit better. So for as far as office hours, right now, because of the current conditions, I don't have office hours available. This is also part of the reason why I'm trying to make sure you guys have recordings of this to be able to go back and reference. The typical standard for GCU is they don't have adjuncts working in doing office hours. It's just something that is hard to orchestrate a lot of times, especially for this circumstance. The good news is you guys do have office hours availability for the other instructors that are teaching these courses. So that's going to be Dr. K, Professor Lee. Both of them are still on 4th floor, I believe. Dr. D has done a lot of SolidWorks, but his time is extremely limited right now. So he's now doing dean role, which is a lot of meetings. And I think somewhere in November, maybe the new associate dean is starting, something like that. So I don't know what experience they have with anything. They typically won't have office hours anyway. Let's see, Professor Kong, Dr. Kong, he for sure has. Who else? Dr. Jones has to some degree. He's also 4th floor. Dr. Kong was 3rd floor. At one point, he was He's been second floor. He might have been moved up to third floor now. I don't know for sure. You guys all know where the engineering offices are, right? In building one, kind of the very eastern end. Most of them are second, third, or fourth floor. I don't think they're first floor is all capstone rooms still, as far as I'm aware. So um, any of those guys can answer questions, even if it's not ideal. That'll give you some examples of being able to see stuff in person. But that's one of the limitations of this. If with some of the success of some of these sections, they decide to go to a full-time online role, then I would have the capability for some open office hours, and I'd be a little bit more flexible. But as it stands right now, I can't do that because of some of the other responsibilities that I have. So best way to contact, that's also a really good question. Best way to contact, the way that they prefer, is first questions through Halo's super awesome messaging system, which is the best in the world. It's also the most purple, and it is what it is. Most of the time, I will be able to see those. I won't necessarily be able to get in and check messages every single day. Email also works. One of the things you do have to pay attention to is you need to send it to kyle.staggs@my.asu or my.gcu.edu. If you try and send it to kyle.staggs@gcu.edu, as far as I know, it will still send there and will not give you an error message, but I will not be able to see it because nobody, including the FBI, still has access to that email. And so I won't ever see those messages. So you need to make sure the email address is exactly like it is in Halo, even though the email system for GCU will recognize both addresses. Long story, because reasons is the answer. Yeah, study groups are a very good idea. That's one of the other reasons why I'm curious to set up a Discord. I just haven't had a chance to do it. So that's something I think will be really helpful for you guys so that you can help each other troubleshoot and things like that. Because the first, like I said, the first about third or so of the class is going to be me demonstrating techniques for you guys. Really, the last about 2/3 is you guys putting them into practice and getting to a level of mastery. That's a thing that's absolutely required, is that you drill on this stuff and practice. And I'm going to throw sometimes 2 or even 3 different PDF drawings at you for a given day. And what we're trying to do is go through and actually build each of those. So as the semester progresses, once we've kind of covered all of the advanced techniques and things, we're going to get a little bit more time specifically to focus on here's what we need to be doing, here's how it's going to work, here's here's how you start applying it to this specific type of drawing. And here's, so I'll have you guys try it first, and I'll give you, maybe about 45 minutes or so to try the drawing yourself, see how far you can get. And then I'll step in and show a demo of here's how to do this the most efficient way, right? So instead of just leaving you guys to, okay, I'll turn my camera off and be back in 2.5 hours and see who's still standing. I'm going to be interacting with you guys and trying to watch out for questions. But if you guys aren't taking advantage of that, and you aren't drilling on this, and actually trying the parts and working together, especially as we get into some of the CLC projects and things where you guys are going to have to define the dimensions for, we'll give you a drawing, but no dimensions at all of multiple different parts. You guys have to collectively figure out exactly how big everything is, put it all together like it's a whole thing, right? So there's a lot that goes into that. So it's something I want to have you guys keep in mind. There's a lot that you'll learn in terms of working together and dimensioning, because we want to make sure that unlike when the Mars probe crashed many years ago now, because somebody thought a dimension was in centimeters instead of inches, we want to make sure that doesn't happen, because we don't want to be watching the news later and go, oh my gosh, I taught that student, right? That would be bad. So we want to try and not have those happen. All right.
I have a quick question for you,
Other
Professor.
questions?
Quick one.
Yeah.
Well, two questions really. Is in one of the introductory assignments, I believe it was the Intro to SolidWorks. On the rubric, it said weight, and I know weight is usually tied to a material. Is there any specific material you want us to select, or is it just generally no material?
Yeah, so we'll talk about materials real quickly while I've got this up, because I can define what material this is. So right now it says material not specified. So what I'm going to do is I'm going to edit material. And I think what we're going to use this semester is, let's see, what's a good one? Some of the materials have a density. Some of them don't. So like glass fibers has a mass density. Some things don't. I want to say maybe it was like some of the plastics that didn't. So a lot of these do. ABS, maybe it was like ABS. No, this one has a mass density. So some of the materials didn't. Maybe it was the carbon fibers that didn't have a lot of them. No, they have those now. So maybe they've updated a bunch of them. It used to be, even a couple versions ago, there were a lot of things. Unfortunately, no, we can't do air for everything. I've thought about it before, but those are usually a little bit tough. Let's see. Let's do actually have, I think, more of the rubbers now, which is interesting. Let's do the Hexel 3000 filament. So what this will do, actually, no, let's do let's do the Thornell at 2000. I think these are close in variation. Yeah, this is most closely the material to what you think of as like a traditional carbon fiber. But what this will do is then when you go to include that, so it's also a really good point today to include like how to submit things. So what you want to do is you want to use the sketch tool, and I'm going to move a couple things around, or the snipping tool. What you're going to want to do in terms of turning in assignments, so this is pretty important for covering today, is you want to take a screenshot that includes all of what your screen is showing at that point in time, so that I can see what your part tree is. The reason for this is I want to know how you guys are approaching each of the different features so that I can see what it is that you're doing, so that I can understand kind of where the misconceptions are, where we need to reinforce all of those things as we're getting toward the CSWA exam. So then you'll have your snip. So you're going to include this. You're going to copy and paste it into a Word document, especially for the case where you're going to select this and you're going to try and show dimensions where you can. So you're going to get another snip of this. So same idea. You're going to show your screen with your details. And then as a last step, you're going to get one more screenshot where you can usually do this on the same screen. Sometimes you don't have room, but you'll see under evaluate and then mass properties. So if you come up with a mug that weighs, 300 kilograms or 850 pounds, obviously something's not Correct. So you want to get a snip, and this is perhaps a more useful one as the last one. So you take this snip and you say, okay, based on this, here's where we are. Here's what our mass is. It'll also show me things like center of mass, etc. So what this will do is this will give me some parameters to see how you're drawing, because here's the thing about CSWA. All of those parts that you make with all of those different dimensions, they're going to leave one or two of those dimensions out of the sketches so that you do not have 100% of the information to get the part exact. It's done that way on purpose. What that allows them to do is, if the mass on this is supposed to be exactly 308.87 grams, your accuracy for mass, and the reason this is in the rubric the way that it is your accuracy with mass has to be within 1% to actually have that part considered to be correct. So 308.87 times 0.01. So you have exactly 3.08 grams of wiggle room. So if you came up with like 312.5 grams minus 3.0887, 309. So you would be out of spec if you were at 312 grams, because you did a fillet wrong or you forgot a fillet or something like that, right? So we'll take a look at what that looks like if we took this fillet and I'm going to close mass properties. So if we took away that fillet, yeah, and we took away this fillet, took away this one, yep, and we took away this one. That's going to change just slightly our mass properties. So now we're 308.78 grams, where we were 308.87 grams, right? So how it's actually lighter with more material is because SolidWorks. So the volume is slightly higher, but this is also why it's important to have a screenshot that you can reference and say, oh, okay, this was 1544.34.8, 1543.88. So this is a lesser volume, and yet somehow the mass is even less where it should actually be more, because those fillets should have taken away material, right? So all of those kinds of little features can push you outside that 1% boundary very quickly. Or if the radius was supposed to be on a fillet a 2mm instead of a 6mm or whatever. So all of those things are going to contribute to you being inaccurate. But the idea here is just to give me a reference point for everybody using the same material. So to clarify, it's going to be this one, the Thornell matte VNA. So it's a matte carbon fiber. I forget what the VMA stands for, but it's a I think that's the angle of the matte layering for layup. So that's a thing that you'll learn about later in a materials class. So that'll be fun. All right, so we covered submissions. Make sure that those are either saved as Word docs or as PDFs, because that works a lot better with the grading system in Halo. If you try and save it as other things, sometimes people try and just upload a screenshot picture. A lot of times Halo still has issues loading those. So yeah, so that's fun. Other questions? Let me see. There's a couple more in the chat. Yeah, so the the first round of assignments, I will be lenient on the late points. The subsequent assignments, we're going to have to keep up pace. I'm going to make some changes on the calendar going forward so that you guys have a clear idea of what's happening. So one of the things a lot of times that I will do is I will set a um, instead of leaving stuff due at Sunday night, one of the things that I'll often do for this class is actually have everything due on either a Thursday night or a Friday night. I'm curious to get a vote from you guys. What of those would work best? The reason being this: if every class waits until Sunday night, being that students start the assignments inevitably, an hour before it's due, right? Because reasons. I find that if students wait until Sunday to start, they're always crunched for time in a very bad way. So if some assignments are due closer to the end of the week, you still have class time, you still have time to ask questions, but then you can get stuff in and done for this class before the onslaught for every other class over the weekend, right? So what are you guys' thoughts on that? It can be a little hard to adjust to, but it's something that actually can be very beneficial to you guys and help boost your scores. Any thoughts? Or do you guys just want to keep Sunday and go for broke? I mean, really go for broke. I mean, your grades going for broke, but that's a different thing.
Quick question. So for this wax project, I didn't know like screenshots, I had to submit all that. Do I have to go in and resubmit that or how do you want that done?
Um, so usually I try and cover some of those details in the first class, but this is why like I don't bother trying to post an announcement with like 8 million paragraphs that nobody will ever read, because it's not effective. Um, for the first round, you're probably fine, so long as you've submitted something for those, because I'll be able to work with, are they clearly doing the thing they're supposed to be doing? Some students have tried to like crop screenshots of the finished part and like it's in bad resolution and stuff, because they've tried to not make the part and just crop like the little tiny thumbnail from the tutorial and blow that up and submit that. Stuff like that doesn't work. So that's truly a waste of your time. Like it takes more time and effort to try and make that look okay than it does to just make the stupid part in the first place, right? So put the effort in for the class and you guys are going to get a lot better results. But as far as like the first assignments, don't worry about that too much. Just make sure that you have stuff submitted so that I can get it graded. So that's where I'll kind of take some of the feedback on submission times and all of those things into consideration, because that'll help maybe make stuff a little bit easier. Not like, there's no way to make this class like no work at all, but it's something that will help to kind of bound the box a little bit. So that's something that might be helpful to pay attention and see. As you guys are doing future assignments, just make sure that they're in a Word doc or a PDF, because those are a lot better with the way that Halo loads stuff. So, yeah, the other thing is, I'll factor in like where you guys are going to be rewatching videos and stuff like that. So that'll be another factor. So I don't know if the Friday will benefit you as much as it would if this were an in-person section. Yeah, I'll have to weigh that a bit. So I'll play around a little bit with the due dates and see what we can make happen, because it might be more effective to have some of this due instead, maybe on a Saturday night or something. So I'll play around a little bit with due dates and see what I can come up with. Some of the bigger assignments, that's why I introduced things like the French curve stuff that you guys want to kind of get started on earlier. You want to try and probably rip through as many of the tutorials as you can, because those will be fairly quick. You'll have kind of the help of the system. That will also help you get an idea of where a bunch of the buttons are, get you more familiar with stuff more quickly. So that's why they're there. So I would definitely go through those and do as much practicing as you can outside of class, because the general rule of thumb is you want to try and spend about 2 hours outside of class for every hour inside of class, which is a lot. So no, we don't need to resubmit to specify the material or anything like that. You just want to make sure that you're getting something submitted for that assignment so that you can get all caught up. And I saw there were a number of messages. I'll try and get to those maybe later today, but hopefully we've already answered some of those questions. So there'll be a lot of variation through the semester that we'll have to kind of tweak and adjust things as we go, because that's the normal nature of this class. So there's a lot of stuff. There will be some instances where you guys are physically 3D printing parts, for instance, and I'm going to get those files as quickly as I can to the techs so that they can get those printed off for you guys, and then we'll give you instructions later on how to get those picked up and to do the measurement and all of those things. So we'll see how all of that goes, because we want to make sure you guys have some connection between what you're drawing and then 3D reality. So, all right. Any other final questions before we wrap up, since you guys are probably reaching like the gelatin brain status? Okay, I don't see any others coming through. If you guys do have further questions, go ahead and the material for every week going forward is going to be this Thornell matte VMA. So it's one of the carbon fiber materials. Come on. It's one of the carbon fiber materials. Every time you have mass properties open, you have to close it before you blow your nose or do anything. It's under the carbon fibers, Thornell matte VMA. So it has a mass density of 2,000 kilograms per cubic meter. That's the material that we're going to use. Different materials are going to give you different results. But what we're looking for is the mass so that we can be within that 1%. So, okay, another SolidWorks question. What's that? Because there may be some install difficulties and things that will be difficult. Check which audio source you're using, because I can see you, but I can't hear you at the moment. It might not be using your built-in mic, or it might be trying to use your speakers or headphones or Bluetooth. That's one of the downsides of this. Not yet. This is another reason why I want to get something like Discord set up so that you guys can jump in and say, hey, I had a problem with this. And you guys can do voice messages and all kinds of other stuff there. So I'll post a link to that as soon as I get a chance to set it up. But I'll keep an eye out for your question in chat. So a couple keys are for the SolidWorks install, especially if you have issues at the install stage, going to see one of the other professors that I mentioned. Dr. K, Professor Tan, to some degree, Dr. Jones, Sometimes Dr. D, but I think his availability is like really bad now. Dr. Kong is a really good one to see about that. They'll all be able to help with issues with the SolidWorks install, especially anyone that's needing to try and install it on a Mac or something like that. You'll definitely want to go see Dr. K, because this will be kind of above and beyond what the tech support group can actually help with, because they don't really understand how some of this stuff works. So their support capability is pretty limited. So I would definitely check in with them. I can try and make recommendations over messages, but it's really, really hard to solve all of those kinds of issues from this end, in terms of the actual physical installs, because every system is going to have different hiccups. General rules of thumb, if you're still in the process trying to install it, you're going to have to get it installed soon, but you want to deselect the SolidWorks composer and things right at like the very last step before it actually starts the install. You want to deselect some of the composer and visualizer stuff, because that's all issues. So the no dimensions, so that's going to need some local troubleshooting. So yeah, I would definitely see if you can go find Dr. K on the fourth floor, because he'll be able to much more quickly kind of zero in on issues. So all right, any other final questions? If not, I will keep an eye out for messages. So make sure that you guys are bookmarking this call, showing up regularly, and I'll try and get Discord and stuff set up so that you guys have a more usable forum for you. So this video, I'll probably be able to post pretty quickly. I'll try and get this one uploaded today so that you guys can go back and review. Some of the time, depending on what the participation looks like, it may take a couple days to get the videos uploaded, but my goal will be to make sure that it's uploaded for that week, before the end of the week, or on Friday at the latest. That way you guys have something to go back and reference as you guys are starting to work on the projects. So that's part of the reason why making sure that you're here and present participating is going to be really, really important, because there's going to be a lot of practice and follow-up that you're going to need. So, all right. Cool. Well, I will stop the recording there, and make sure that you guys have what you need. So you guys